Years casting that.
I'm David Gregg. I have a master's and PhD in chemical engineering from the University of Illinois. Afterwards, I went to work for Lawrence Livermore Laboratory, where I worked there for more than 30 years. You cannot get a flame hot enough to start the metal to molten, make it molten in the first place so that this other process takes off. I don't know of any mechanism for that. The only way that's known that a carbonaceous material can cause steel or iron oxide to turn into a molten metal is in a blast furnace. Yeah, and that's very different than what we had.
An incendiary used by the military, thermite is a compound of iron oxide and aluminum, which when ignited sustains an extreme heat reaction, creating molten iron. In just 2 seconds, thermite can reach temperatures over 4,500 degrees Fahrenheit, quite enough to liquefy steel. We know that open-air fires cannot burn hot enough to melt steel, but metal had melted at the base of the towers.
The next question is how do you get the sulfur in these pieces of steel or in the debris, and that question is unanswered. There's a version of thermite called thermate, which has sulfur in the thermate and what the sulfur does is it's sort of like salt on ice.
Appendix C of the FEMA report describes sulfur residues on the World Trade Center steel. The New York Times called this the deepest mystery of all. Sulfur slightly lowers the melting point of iron, and iron oxide and iron sulfide.
And it just basically makes the steel melt at a lower temperature. So instead of having to bring the steel up to 1500 centigrade, you can slice through it with material that's at 900 or 1000 degrees centigrade. And if you do a search on Google for thermite and building demolition, you can find all sorts of wonderful devices that have been fabricated and invented that use thermite for building demolitions.
Thermite is, in the old-fashioned thermite, is a mixture of pulverized aluminum and pulverized rust. And if you can get this mixture to react, which is not so easy, it produces tremendous heat, and this is what you call an incendiary. An incendiary is something which can be used to destroy something by the means of heat, while an explosive is something which acts with pressure. It knocks things apart. Now, the old-fashioned incendiary is not an explosive, but it is still used for military purposes for melting iron structures.
Practical applications of thermite involve things such as equipment decommissioning in the military. When they have a piece of artillery or a tank or something like that that they don't want to leave behind to the enemy, they throw what are called grenades, thermite grenades down the barrel, let's say. But thermite does not explode. It simply reacts, produces large amounts of heat and molten material.
In the case of thermite cutting charges, you would have heard far less noise since they are worked by thermal heating, melting of the steel, rather than an explosive cutting as in RDX charges.
I'm Kim Ireland. I have a degree in chemical engineering from Clarkson University in 1963. After graduating, I served 2 years as a reserve officer in the U.S. Army Corps of Engineers, where, among other things, I had training in explosives such as C4. I was involved in the industrial chemical industry for 20 years with major companies. There were reports of molten steel having been seen in the rubble pile of all 3 buildings, and I knew that jet fuel, which is essentially kerosene, is not capable of melting steel nor iron. Kerosene or jet fuel burns at less than 1600 degrees Fahrenheit, and molten steel needs at least 2700 degrees Fahrenheit in order to melt.
The thing that most struck me about the 9/11 incident was following the incident how overflights had detected with infrared camera 1400 degree Fahrenheit hotspots on the surface of ground zero. And that being there for a week, you know, indicates that there was something very hot going on below the surface.
Another question that may haunt the new Freedom Tower. According to USGS, they found as much as 6% of the World Trade Center dust consisted of tiny, previously molten iron spheres. What does this tell us about the temperatures generated in the tower's destruction?
My name is Adam Parrott, and I have a bachelor's degree in chemical engineering from Queen's University. I've been working for an environmental consulting firm for a number of years. When the USGS collected samples of the World Trade Center dust, they found the iron microspheres. Insofar, the USGS does not have a valid explanation for the presence of these iron microspheres.
But I've independently seen thermitic activity within 2 separate independent samples of World Trade Center dust.
I'm Jerry Lobdell. I'm a retired physicist and chemical engineer. I have a BS in chemical engineering from Texas Tech, and I have extensive coursework in mathematics and physics from the University of Texas at Austin. I've had broad experience in analysis and applied research, 30-year professional history spanning physics, chemical engineering, statistical analysis and modeling, and operations research. So what do the microspheres contain? Iron is the main element, and then it has smaller portions of aluminum, sulfur, a trace of manganese, a trace of potassium. Most of them are less than about 1/10 of an inch in diameter, and they're spherical, and they're found in all of the dust blown out of the buildings during collapse, no matter where in Manhattan that dust is picked up.
You must have had a much hotter heat source for you to get 2,700 degrees Fahrenheit in order to melt the steel, melt the iron, to get these spheres, these molten spheres. Your heat source must be something like a chemical reaction, an exothermic chemical reaction that reacts, in the case of thermite, reacts at 4,500 degrees Fahrenheit.
My contention, based on finding thermite residue in the dust, is that it happened before. It didn't happen after in the fires that ensued in the rubble pile afterwards. It's all the characteristics of the microspheres, along with what I see in the attack of the beams that were actually found, tell me that thermite was involved in melting those steel beams.
Out of the ashes of the World Trade Center devastation rises the Freedom Tower, whose foundation, however, is shrouded in question. For example, in the World Trade Center dust, an international team of scientists find an advanced form of highly energetic nanothermite composites. What is it, and where does it come from?
My name is Niels Harriet. I have a master and a PhD in chemistry, and I'm associate professor at the University of Copenhagen, and I have been so for almost 40 years. I have published close to 60 peer-reviewed papers in the best journals, and currently I'm involved with research X-ray time-resolved spectroscopy on time scales of 1/millionth of a second. In the dust we found what we characterize as unreacted thermitic material in the shape of some very tiny red-gray chips, which have different properties. Most importantly is they're still reacting, some of them, and in the reaction they produce molten iron, which is the prime indication of a thermitic reaction, and such a reaction can be used to destroy steel structures. What we have found is a modern version of thermite, which we call nanothermite, which is produced in a different way. It is not just two powders being mixed. The material is actually built from the atom scale up. We call it the bottom-up procedure, which is what you do in nanotechnology. This has two consequences for the nanothermite, which distinguishes it from the classical thermite. First, the ingredients are much smaller, which means they are reacting faster and they are more easily ignited.
The primary elements in the red material are aluminum, iron oxide, as well as silicon and carbon. The iron oxide appears in faceted grains, approximately 100 nanometers across. The aluminum appears in thin platelets, about 40 nanometers thick. It is the small size of the particles involved in this material that allow us to characterize it as nanothermite. In ordinary thermite, the particle size is much larger, and hence ordinary thermite is an incendiary, whereas as the particle size becomes smaller and smaller, it can become explosive. Super thermite is sometimes called. This red material contains also a significant amount of carbon, and the formulation of nanothermite as described by National Laboratory publications also implies the presence of carbon, very typically. The organic is used with nanothermite in order to produce gas, that is a very high pressure gas that makes the nanothermite an explosive. We do have descriptions from the Livermore National Laboratory in particular of how they fabricated this material, but to fabricate it is not so easy. This is discussed in our paper in the Open Chemical Physics Journal, published in April of 2009. So far, none of these papers have been refuted in the literature, the scientific literature. So that means they are unchallenged in the scientific sense. They stand as an indictment, really, of the official story of 9/11.
One of the things I'd like to stress about these chips is that they really shouldn't be there. They're not a natural formed agglomeration of aluminum from the aircraft or materials that were in the building and iron oxide that got knocked off. It isn't just a haphazard bringing together of iron oxide and aluminum, which is the basic components of thermite. This is a material that is made up of nano-sized particles that are all very uniform, very symmetrical.
The formulation of the gray chips is nano-sized. This cannot be paint. Paint does not have these exotic properties. It's impossible.
We do not know which role is played by the red-gray chips that we found in the dust. But we know, and this was already totally clear before we started investigating the dust, that both explosives and incendiaries were used in the controlled demolition of World Trade Center. This is quite obvious because of other observations, the molten iron and other findings in the dust.
This is material that is of military use that really shouldn't be there.
And our whole society is being led to believe that these fundamental laws of physics, hard science, don't apply anymore. I think that should really frighten all of us.
Just all the other evidence of seeing flashes and explosions and the melted metal and the dust particles and with the explosive chemicals found in the debris. There's just a lot of questions about what's been going on, and that these questions have not